Oh, back off, back off. Oh, he's concussed. We need a stretcher.
Yeah, baby!
You probably don't think this happens a lot, but it does. In fact, football is a very dangerous sport. Take a look at these clips.
Here comes the, here comes the, here comes the. Y'all don't really want it like that. Yeah. Here comes the, no, here comes the. Oh.
Now, what's the solution to this? You may not think it, but it lies in physics. Let's go take a trip to Professor Finesser to see what he has to say. We're here at Professor Finesser's laboratory. Let's hear his input on that sick collision.
Hey, Mr. Malice, how's it going? Well, as you can see in that collision, both players had large amounts of momentum, which is defined as mass times velocity. When the players collided, their collision was an inelastic collision, or in other words, they stick together. In this inelastic collision, the momentum of both players changed. The change of momentum is defined as impulse. One of the formulas for impulse is force times time, but we have a problem arising now. Because impulse is constant, what are we gonna do? Well, because impulse equals force times time, we can't change the impulse, but we can change the time. If we change the time to make it larger by making both players wear better and safer pads, then we decrease the force. In fact, this process is happening in the NFL, and people are researching new ways to make safe and effective pads for players by increasing the time of collision, thus reducing force.
Interesting.
Kick off.
Timeout again.
This doesn't look good.
Let's go talk to Professor Finesser. We're back here with Professor Finesser to talk about kick returns.
Oh, hello there. Caught me at a bad time. Well, the thing about kick returns is that there's another collision. But if we are already improving pads, how can we improve kick returns? Well, in fact, officials in the NFL have actually reduced the distance required in a kick return. But how does this relate to physics? Well, let's say a player is accelerating in a kick return at 2 meters per second squared. We're using the formula VF equals VI plus AT. If the player travels a shorter distance on a kick return, they have a shorter time, thus reducing T and reducing the velocity final. With a lower velocity final, they therefore reduce their momentum and reduce the overall impact of the collision. Maybe one day you lads will be using your physics knowledge to help make safer rules for the NFL.
Again, very interesting. Okay, one more play in the game. Timeout number 3.
This does not look good.
Professor. Well, we're here again with Professor Finesser to find out how to improve collisions with the ground.
Hey man, Professor Finesser here. You might not think about it this way, but when a player hits the ground, it's actually a collision. The player falling has momentum, but when they hit their ground, their momentum changes. This is known as impulse, as mentioned before. So, we can't change the impulse, but how do we change the force applied to the player? Well, similar to the pads mentioned before, we can use our knowledge of physics to change the force applied to the player. For example, today, researchers in the NFL are putting soft layers of material underneath the turf in order to increase the time of collision, thus reducing the force. This knowledge of physics has helped researchers make the ground safer for players' bodies, legs, and ankles.
Ultimately, very interesting. However, Professor Finesser, I can't help but wonder, are you actually a professor?
Professor!
Professor!
Professor!